Yeah, you could do it in metal. Do you have something to cover it with? So is that like a thermos to keep it hot? And does it work? Probably not really.
So we went to 36 size, one size is smaller than what I do. He gave me one. So that's what I went up to. Whenever I went up to dance, I'm right there like 90.
Yeah. And I was running hella late, all stressed out. Listen, me and my kid got into such a fight this morning. It's like the worst.
Do you not know all day?
I do, but I think since we were kind of mad at each other, he walked all the way around the front of the school just to like show me how mad he was at me. Because what happened is, I've been telling you, pack your lunch the night before. You're both kind of late, you don't like get up that quick. And he's been like kind of not feeling good, like he's felt like this morning. So he doesn't drink his lunch. He takes 100 years to meal prep. Takes 100 years to make whatever lunch. He doesn't put carrots in it. So I felt all the time that I wanted to eat it. So he sent a doctor to put carrots in it. So he doesn't put vegetables in his lunch. It's just he makes like kind of like what I drink, just like caffeine, but it's not. I don't like coffee. So since he's sick, I was made all feel all over the floor. So literally have a 35-minute drive. We fought them. So I was like,
I see it too, but I haven't seen you do it. Behind your back. It's cross, right? And it's like,
so whenever I pulled in, he was like, I walked her to the front. And like, we like so got into it, but yeah, usually he does walk in. No, we were just beefing. All right, y'all. Today we are gonna do definite integrals. That's a great question. You have two class days and then test. So it won't be this 2 A-days and then test. So it's in like a week. 2 days after today. And you'll have a day to review and kind of let it sink in before you test. Okay. So today we are going to cover a definite integral. Now let's talk about, we've already covered what an integral is. Okay, but the integrals that you've done so far have been called indefinite integrals, and it's because you do not have a number on the top and the bottom of the little s symbol. So this is an indefinite integral, but you'll notice that the integral symbols that you see on your notes today, do you see how they have like numbers on them? Okay, so let's talk about the difference. If you have a definite integral, meaning you have a number on the bottom and the top, that represents the area enclosed by the function f of x and the x-axis on the interval from A to B. So if you cannot graph, okay, that might make these notes a little bit harder for you, but most of your homework is already graphed for you that you're just doing the area part. So let's take a look at the first example. You have the integral of 2x from 0 to 4. First thing I want you to do is graph what y equals 2x would look like. So 2x would be linear. And if you don't remember, it's y equals mx plus b for lines. So if there's not a b in the formula, where does the line start? At 0. Very good. And then 2 would be called the slope. So you would go up 2 over 1, up 2 over 1, up 2 over 1. Okay, so go ahead and do that for me. And then if you wanted to extend the line back the other way, you could just go down 2, back 1 like that. Okay, once you have those dots, go ahead and connect your straight line. And then remember that this integral is going to be how much area is enclosed by the function you just drew and the x-axis on the interval from a to b, where a is the bottom number and b is the top number. So what I mean by that is you're going to shade along the x-axis starting at 0 and ending at 4. So 0 would be here till 4. And then you're going to shade between the graph you just drew and the x-axis that you highlighted. So I'm going to stay between these, between these, between these, between these. And you'll notice that you highlighted a shape that you already have a geometric formula for finding the area for. What shape is it? That is a triangle. How do you find the area of a triangle? Okay, b times h over 2 or 1/2 base sum type. Okay, now talking about our triangle, how long is the base? 4, how tall is it? Close? It should be 8, yeah? Okay, make sure that when you're doing your graph, you kind of count it out carefully. So the height should be 8. So then it'd be 1/2 4 times 8. 4 times 8 is 32. Cut it in half. Final answer is, oops, I can't do that. 60. Okay. Next one. Our equation is x plus 3. So we're going to graph y equals x plus 3. Okay, so the 3 is the y-intercept. And then I notice that this time I don't have a slope. What does that mean the slope is? 1 over 1. So I'm going to go up 1 over 1, up 1 over 1. Make sure your graph is pretty accurate so that when we're counting how long stuff is, your graph is good. Okay, then I can also go 1 over 1 the other way to extend that line to the left. Now, what interval am I going to shade the x-axis starting at? -2 till when? 4. So -2 is here. I'm going to shade the axis first to 4. And then I'm going to do all my shading between those two functions, between the x-axis and the graph, starting at -2. And I'm just going to fill in all the missing space till I get to 4. Is that a triangle? No, but it does have a name. What shape is that? Trapezoid. Very good. So the area of a trapezoid is going to be 1/2 base 1 plus base 2 times its height. Now, one thing you have to know about trapezoids is that the bases have to run parallel to each other. So it's not necessarily the top and the bottom. It's the sides that are parallel. So in this case, you should notice, I'm going to highlight the bases in pink, that it should be this one and this one. Okay, this is, let's say, base 2, and that side is base 1. But they have to run parallel to each other. Okay, so if those are my bases, how long is base 1? How many boxes? Just 1. How long is base 2? So I would do 1/2, 1 plus 7. And then when you multiply by the height, remember your trapezoid is kind of tipped over. So if I tip it back over, my height would be the boxes this way, which would be how many? Okay, so if you want to label that from here to here, that would be your H. Okay, but it would be running between the bases. 7 plus 1 is 8, times 6 is 48, cut it in half is 24. Now, you'll notice that all of the shading we've done so far has been for areas that are above the x-axis. So, consequently, if you have any area that is accumulated below the x-axis, the integral's value will be negative. Now, it doesn't really make sense to say the area is negative. Area itself is always positive, but when you're doing an integral, you'll assign a negative to any area you find on the bottom. So let's do the next one. What equation are we graphing for example 3? 2/3 x minus 4. We're going to graph that. So the -4 is the y-intercept. And then 2/3 will be the slope. So you're going to rise 2, run 3, rise 2, run 3. Okay, remember, you want a pretty accurate graph as best as you can. Same thing the other way. I can go down 2 and back 3 to extend my line to the left. Okay, from there, what section of the x-axis are we going to shade along? Starting at -3, stopping at 6. Very good. So -3 is here. I'm going to shade all the way to 6. And then I'm going to shade the area or the space between the x-axis you just shaded and the line. So that would be here to here, all the way till 6. What's our shape? Triangle, which is going to be 1/2 base times height. My base in this case runs from 3 to 6. How many units would that be? Sorry, -3 to 6. That would be 9. And then how many down? So that'd be 1/2 9 times 6. So that'd be 54. Cut it in half would be how many? Close? 27. Now, the area is 27, but the integral would equal -27 because of where that area is accumulated. So if it's below the x-axis, you would take the value of the area and then turn it negative. Okay, next one right next to that. What is the name of those bars that we see? Very good. And do we remember the shape of an absolute value graph? V. Okay, -1, which way are we shifting, left or right? Right, and then down 3. So go to the right 1, down 3. And then if there's a slope in the front here, like let's say like a 1/2 or 2/3, you would do it. But if nothing's there, it's a 1/1 V. So you're going to go 1/1 this way. And then you're going to go 1/1 up the other way to make your V. So remember, it should be symmetric around where that vertex is. All right, next thing we're going to do is shade the x-axis. Where are we going to start that? What number? -2. That would be here. And then we're going to shade the x-axis all the way till 7. And then what you're going to notice is that part of it, the green line is the top of the region. And then for this part of it, the green line's on the bottom. It doesn't matter. When you shade, you stay between. So that means when I'm shading here, I'm going to stay between. And then as soon as they flip-flop, I'm going to still stay between, but I'll just be shading above the x-axis on the little remainder of that interval here. Okay, let's find our areas. I want the area of this triangle, 1/2 base times height. How long is the base? How many boxes? 6. And how tall is it? 3. So it'd be 1/2, 6 times 3. 6 times 3 is 18. Cut it in half is going to be 9. Now, 9 is the value of the area. What will the value of the integral be? -9 plus. Notice for this second area, I'm assigning a plus to it because that triangle is above the x-axis. I'll do 1/2. This is 1, 2, 3. 1, 2, 3. So if it's 1/2, 3 times 3, that would be 9 divided by 2. So we'll say 4 point. And then in your calculator, -9 plus 4.5 would be -4.5 for your final answer. Okay. Go ahead and turn the page when you're ready. Okay, next example that we're going to do is the bottom row. We'll come back to those top graphs, but go down to the bottom row in pre-cal. You should have spent a little bit of time on piecewise functions. So I know these are a little bit tricky to graph, but let's review how to do it. So whatever this number is here, that's where you're going to split from one graph to the next. So in this case, my split is going to happen at 0. Every x to the left of 0, I'm going to use the function -4. So I'm going to put y equals -4 for all of the x's left of 0. Then once I cross to the x's greater than 0, I'm going to use the 2x minus 2. So on this side, it's going to be 2x minus 2 for all the x's greater than or equal to 0. Now, let's start with the straight line because we've already practiced a few of these. So 2x minus 2, where would I start on the y-axis? -2. And then if my slope is 2, that's the same as 2 over 1. So I'm going to rise 2, run 1, rise 2, run 1. So starting here, up 2 over 1, up 2 over 1, 2 over 1, 2 over 1. But notice I'm going to start at that yellow line and I'm only going to connect to the right because this equation only gets used for the x's that are greater than 0. Now let's talk about the endpoint. I have an equal to. Do I do an open or a closed circle? Do you remember? Closed is correct. Okay, for the left side of my equation, I just want y equals -4. That's just going to be a flat line at -4. So come over here to your graph at -4 and then draw in a flat line going to the left forever and ever. Okay, that side had an x less than 0, which means it would get an open circle. Now, what section of the number line are we going to shade? Very good. Right here, it says only from -4 to 6. So I'm going to go to my x-axis and I'm going to shade starting at -4. And then I'm going to cross all the way through to 6. Remember, our goal is to stay between the green line I just shaded and then the graph I just drew. So I'm going to shade here. And then once I hit 0, now I'm only going to be reaching to where the new graph is, which would be here. Okay. And so what you're going to notice is that rather than you just having one shape, you actually have a total of 3 shapes. You have this first green rectangle right here. You have a little baby triangle, and then you have a big triangle. So let's go one at a time, starting with the rectangle. What are the dimensions? Okay, it's a 4 by 4. What's 4 times 4? But I'm going to call it -16 because that area was accumulated below the x-axis. Okay, next let's do our big pink. So this is 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 times 10 is 50. Cut it in half would be 25. Okay, then don't forget this little baby right here. 1/2 base times height. My base is a 1. My height is a 2. 1 times 2 is 2, but then I have to cut it in half. So it'd be a 1. Positive or negative 1? Negative 1. So I have a negative 16 plus a negative 1 plus a 25. What would my final answer be there? 8 is correct. All right, let's try the next one. My divider line is going to go at what x value this time? 2 is the break point. Okay, so I'm going to sketch that divider line in. Every x that is less than 2, I'm going to use absolute value x. And then everything on the other side, I'm going to use just a 4. It'd be y equals 4 or x greater than. Okay, let's do the bars side first. Now notice you don't have any pluses or minuses, so it's going to stay right at 0. And then my slope is going to be a 1. So I'm going to go 1, 1. Am I going to keep doing dots though this way? No, because once you hit that line, that equation is inactive. Okay, then I'll go this way. And then draw your V. For the other side, my equation's just a 4. 4 will be a flat line. And it'll go for all the x's greater than 2, means it's going to go to the right for forever. Which of those will get an open circle, the V or the line? The line, because if it's like this is going to be your open endpoint. This one would be closed. So I'm going to put an open circle right there. Now, the good news for you is it actually doesn't matter what kind of circle it is because we're finding area anyway. Okay, but go ahead and shade where you think you should shade. So our integral this time is -6 to 2. So do your x-axis first, then fill in the gap between the x-axis and the function. Okay, so your graph should look somewhat like that. Okay, and then how many shapes do we see that we have? 3. We have 2 triangles that happen to match each other, and then we have a rectangle. Will any of those areas count as negative? No, because they're all above the x-axis. So for this one, it'll be 1/2 base times height, which is 2 times 2. 1/2 2 times 2 is going to be half of 4, which is 2. Notice that I know this one's the same, so I'll just put another +2. And then for my rectangle, I see that that's 1, 2, 3, 4. 1, 2, 3, 4. So 4 times 4, that would be a 16. So an overall integral value of 20. Yes. Huh? It is a square, but remember, all squares are also rectangles. And rhombuses, if it's a square, and a parallelogram. Shall I go on? Also a polygon. Okay, good. Okay, go up to the top. All right. In pre-cal, you should have covered how to graph a circle. So in case you don't remember, I'm going to give you the equation for a circle up here at the top. Okay, it's x minus h squared Okay, write that down. The equation for a circle is going to be x minus h squared plus y minus k squared equal to r squared. Now that circle is going to be centered at HK, and then the R is going to represent the radius. Okay, now I do not expect you to just randomly remember that, but we're going to do 4 examples to make sure you understand how to do it. Okay, so first thing I want you to do is I write big, so I'm going to write on this sticky note. Okay, but do y equals, and then the square root of 25 minus x squared. Okay, we need to take this equation and we need to put it back into the graphing version of the equation for a circle. So the first thing that you're going to do is you're going to square both sides. So I'm going to do squared, squared. Now, what happens when I square on the square root? Goes away. Very good. So now we have y squared equals 25 minus x squared. Okay, then look at your standard equation for a circle. Okay, my x and my y are both supposed to be on the left side together. So I'm going to take my minus x squared and I'm going to add it across to the other side. So I have x squared plus y squared equals 25. Bless you. Now, this circle doesn't have a number in the H or the K spot. That means it is going to remain centered at 0, 0. And then if my r squared is a 25, what will my r be? 5. Very good. So I want you to draw for me a circle centered at 0, 0. And then with a radius equal to 5. Okay. So let's come over here. I'm going to move my sticky over. Okay, we're going to do a dot at 0, 0. And then I'm going to count 5 to the right, 5 up, 5 to the left, 5 down. Now, don't connect the dots yet with a circle. Okay, listen. This is the entire circle. But when you solve it back to this form, remember when you take a square root, you get a plus or a minus. You know this? Yes? Okay, when you take the positive square root, that's going to be the top half of the circle. Versus, do you notice over here, the only difference between these equations is this one has a negative in the front? Okay, this would be the bottom half of that circle. This is the top half. So we're going to put, this is positive square root, means the top half. Versus this is a negative square root, that means it's the bottom half. So for the first picture, I'm only going to connect this part. And then on the second picture, I'm going to do the same thing, centered at 0, 5, 5, 5, 5. But I'm only going to connect the bottom half because on the square root, I see that I have a negative in the front. Okay. Once you have drawn your circle, okay, let's shade our x-axis. For the first one, we're going all the way from -5 to 5. And do we remember how to find the area of a circle? Pi r squared, very good. Okay, now if I only want half of the circle, then I'll do pi r squared, cut it in half. What is my r for this circle here? Okay, here to here is 5. So that would be pi times 5 squared. That would be 25 pi. But remember, that's for the full circle. We only want half of it. So it would be 25 pi over 2 for your final answer. You could divide it if you want and do 12.5 pi. That would be fine. Okay. Next one. So we're still shading. What are we shading on though? What interval? Only 0 to 5, so that'd be here to here. And then remember, I want to stay between the semicircle and the x-axis, so I'd only be shading this much of the circle. Will I divide the 25 pi by 2? You'll have to divide it by 4. So it'd be 25 pi over 4. Is that done? Negative. Very good. Okay, very good. Okay. All right, once you have that, I want you to try to do the same thing for this equation. So write y equals 2 plus square root 16 minus x squared. And then I want you to try to put it back into the equation of a circle. So it's y equals 2 plus 16 minus x squared. What are we going to do with the 2? Minus it over. So now it's y minus 2 equals square root 16 minus x squared. Okay, then from there, I'm trying to get rid of the square root. So when I square this side, watch, I'm going to have to group and square this side, which means that now the y and the minus 2 are together in parentheses. Okay, that's going to cross the squared and the square root out. So I have y minus 2 squared equals 16 minus x squared. And then last step, take that minus x squared, pushed across to the other side. So you'll have x squared plus y minus 2 squared equals 16. Okay, that is your equation for the circle. Can you tell me where it will be centered? 0, 2. So notice my x is alone. That means I'm not going to move it side to side. And then remember, if they put a minus 2 in your parentheses, you're really going to go up 2. So your center is going to be at 0, 2. What will my radius be? Radius squared is 16, then the radius would be. So go to 0, 2 on your graph. And then I want you to count out 4 in each direction. Was my square root originally a plus in the front or a minus in the front? This is a plus. That means it's the top or the bottom half. Top. So I'm really only going to do my 4 this way. Because I know I'm not going to need to connect the bottom half of the circle. So your graph should look like that. What part of the equation are we shading? 0 to 4. So 0 to 4 is here, which means that I need to shade all the way up to my graph. So that would be like this. And then the problem is that's not really a shape, but it can be broken down into 2 shapes. What would we say the bottom shape is? A rectangle. You'll find the area of the rectangle, then you'll find the area of the quarter circle, and then you'll add them up. So the rectangle is how big? 2 by 4 makes it an area of 8. And then for my circle, it would be pi r squared. My r is 1, 2, 3, 4. So 4 squared, that would be 16 pi. But remember, that's for the full circle. And I don't want the full circle. How much of it do I want? Just a quarter. So if I want to divide that by 4, that means the top is only 4 pi. So your final answer would be 8 plus 4 pi. Okay, notice that we would be adding both of them because they're both above the x-axis. All right, you have one more. Give it a shot. Yes?
The other one, why did you start with y squared instead of plus y equals?
I actually started with y on both, but for this one, I just didn't have a number to move over, so I could square right away. That's a good question. All right, so see if you can do that last one. Rebecca, you look absolutely horrified. Okay, so write y equals, write it down first.
Wait, why?
Whatever the equation is here is what you're graphing. So you would graph y equals 4 minus square root 9 minus x squared.
We distribute the negative to the 9 and the x squared.
When you square, the negative in the front will cross out.
Oh.
So what number, Rebecca, do we need to move over first? Take a guess. The 4. And if it's a positive 4 here, when I scooch it over, it's gonna be a what? Negative. And then I have negative 9 minus x squared. Okay, from here, I'm trying to get rid of this square root. That means I'm gonna square both sides. Now, I can ignore the negative, here's why. When I square this, what is negative square root times negative square root again? Yeah, the negatives are gonna cross each other out, and then the squares and the square root will cross out. So all you're gonna keep is the 9 minus x squared, just like we did last time. So you'll have y minus 4 squared equals 9 minus x squared. And then remember that standard form for a circle, your x squared and your y squared are supposed to be on the same side. So you'll take your minus x squared and just push it back. So it'll be x squared plus y minus 4 squared equals. Then the number with x tells you which way to shift it, left or right. Do you have a number in that spot? So you're not going to move it left or right. What about the minus 4? You're really going to move it up because it's always the opposite since it's in parentheses. So your circle is centered at 0, 4. That would be here. And then what's your radius? 3. And is it a top half or a bottom half? Look back at the original. Was it a plus or a minus on the square root? A minus means it's the. So you would go 1, 2, 3, 1, 2, 3, 1, 2, 3, and then put it down.
So whatever draw the line, we draw on the bottom, right?
You have to connect back to the x-axis, correct?
Would that make it too tiny? Well, it would.
Would
Unless
it?
they're a tiny rectangle and
Yeah.
a circle.
Kind of. Okay, y'all, you should be here. Okay, so we're doing the bottom half of the circle because of the negative in the front. If you need me to walk you through this, I'm happy to do it later, but you can see it right there. So this is my equation. What do I have to connect back to? The x-axis, which means that I'm going to go -3 to 3. And then my graph is here to here, which means that you're not actually shading the circle. Do you see that? Okay, the circle is being left open. So how can I get the area of the green? Very good. Okay, to get this area, perfect. You're going to do the big rectangle and then minus the half circle out of it. Okay, so go ahead and write that down. You're going to do area of the rectangle. And then you're going to minus the area of the semicircle. Okay, so using those two areas, you can find the leftover green area. So let's start with the rectangle. Okay. This is 6 across, and it's 1, 2, 3, 4. So 6 times 4 is what? 24. And then for my semicircle, it'd be pi r squared. My r is a 3. So 3 squared would make that 9 pi. But then remember, I don't want the whole circle. I just want half. So I'd cut it in 2. So your final answer would be 24 minus 9/2 pi. Okay, or if you like 4.5 pi, that's the same thing. Delta Math will take either one. So will the AP. Questions on that? Okay. Huh? We're almost done. All right, turn the page. All right, we are not going to finish the last back side of this page, but we need to finish the front and then we're done. So you have 5 properties at the top of your notes. All right, girls, we ready? Okay, if you do an integral, from A to A, that means you're going to start and stop at the same number. How much area are you going to accumulate? If you start and stop shading at the same number, 0 is correct. Okay, let's try to refocus. We have about 15 minutes left and then we're done. So if you start and stop at the same value, you're not going to accumulate any area because you won't actually shade anything. Okay, second rule is that if your integral has the bigger number on the bottom and the smaller number on the top for your endpoints, like if they're out of order, you're going to change the sign on what the actual integral is. Okay, which we'll talk about that in a second. But for now, if the endpoints are backwards, you're going to reverse the sign of what the actual integral is. Next one, if you have a multiplier inside your integral, you can pull that number to the outside, find the integral, and then just multiply afterwards. Okay, the fourth property. If I integrate from A to B, and then I stop, and then I go from B to C, that is the same as if I went straight from A to C. Now, this rule makes sense if you think of it as a graph. So I'm just going to give you a little picture here. If I start at A and I integrate till B, let's say B is here, I would shade all the way from A to B. And then what's the second part of my integral? Picking up at B and going to C. Then is it the same if I just start here and stop here with no stop in the middle? Yes. Okay, so this one should make sense. Okay, last one is that F and G, if they're in the same integral, you can split them up each into their own and then just add the answers together. Okay, which is just like for limits, that if they're in the same limit, you can find the answers separately, add them together at the end. So let's run through some examples and then we're finished with our notes. So take a look at A. I want the integral from 1 to 1. What would I get? 0. That's your first property. Okay, I'm not going to accumulate any area if I start and stop at the same value. Okay, the next one is I want the integral from 8 to 4. But you'll notice that the integrals they've given me almost is that, except for what? 4 to 8 is 6. Then what would 8 to 4 be? Very good. So I'm going to put backwards on that. And then if my original value is a 6, that would be a -6. Okay, next one I want is from 1 to 8. Now they didn't give me F from 1 to 8, but they did give me F 1 to 4 and then 4 to 8. So what can I do with those two numbers? Add them up. Now I'm going to show the property in between. You would break that into 1 to 4 plus 4 to 8. And you know that that answer would be the same. So if I want to go straight from 1 to 8, I can stop at 4 because I have an answer for 1 to 4 and they gave me an answer for 4 to 8. What's the answer for 1 to 4? -2 plus the answer from 4 to 8 is 6. -2 plus 6 gives me 4 as my final. Okay, look at letter E. Instead of 1 to 8, I want 8 to 1. What am I going to do to the 4? Turn it negative, because if 1 to 8 is 4, then 8 to 1 would be -4. And then what would I times it by? See the 3 that snuck in there? You would just times it by 3. You'd get -12. Next one, I want 1 to 8 of f plus g. Well, then I can do 1 to 8 of f plus 1 to 8 of g. 1 to 8 of f, I already did right here. What was my answer? 1 to 8 came out to be 4. And then my answer for g, they gave me right here. 1 to 8 on g, what's the value? 10. So 4 plus 10 means that would be 14. If 1 to 8 is 14, what would 8 to 1 be? Negative 14. Very good. Okay. Bottom row, or bottom section, integral 2 to 2. Doesn't even matter what the graph looks like. What's that integral going to be? 0. Integral from negative 2 to 2. What shape are you highlighting? Look at your graph. Negative 2 to 2 would be here to here. And I have to stay between the graph and the x-axis. What shape did you highlight? Semicircle. So it'd be pi r squared. But what's your r? R is from the center to the side, so it'd be 2 squared. So it'd be 4 pi. And then we're going to cut it in half, which would make it 2 pi. What is the difference from the answer here to the answer here? This one's backwards, which means it would be negative 2 pi. Okay, next one. I want the integral from negative 7 to negative 2. So negative 7 would be here. Negative 2 would be here. What shape did you highlight? Triangle. Area of a triangle is 1/2 base times height. My base is 1, 2, 3, 4, 5. My height is just 1 unit. 5 times 1 is 5. Cut it in half is 2.5. Is that the correct answer? Negative 2.5, because where's the area? Below the x-axis. Now go ahead and skip to right here. What is this integral going to be?
Positive.
Flips it to positive because it's backwards and it's below. So those negatives are essentially going to cross each other out, make it a positive 2.5. Okay, if I want to go from negative 7 to 0, that means I'm going to have to accumulate 2 different shapes. So from negative 7 to negative 2, I'm going to get my little triangle. And then if I stop at 0, how much of the 4 pi circle am I going to get? Only 1 pi. Because I'm not taking the whole top half, I'm only taking the first part. So if this is negative 2.5, and this is pi, your answer would be negative 2.5 plus pi. Okay, and for your homework, you would not be expected to put that in the calculator. You would type it in just like that. Okay. Bottom row, we want the integral from 2 to 5 of 6f of x. Then you're going to find the integral 2 to 5, just times the answer by 6. So from 2 to 5, what shape are you shading? Triangle is correct. And then 2 to 5 would be here. So it's actually 2 triangles, right? You have this guy on top. And then you have this little baby on bottom. So for my top triangle, it'd be 1/2. What's my base? 1, 2.5. So we'll say 2.5. And then my height is 3. So let's go ahead and put that into the calculator just to get a clean decimal there. 1/2 of 2.5 times 3 gives me 3.75. That's for the top one. And then for the bottom one, what would my formula be? What's my base? 1/2. times my height is 1. And then 1/2 times 1/2 would be 1/4. Okay, that would be 0.25, or if you like a fourth, you can use that. Okay, so for my answer, how would I write it? What would I do with these two values? Add them? Good, so I do the 3.75 take away the 0.25. So that gives me 3.5. Is that the correct final answer? 3.5 times what? 6. 3.5 times 6 gives me 21. Okay, we're gonna skip this one for today. We'll come back and do it next time. Last one, what about the integral from 4 to 5? 4 to 5. So 4 would be here. 5 is here. So you're gonna have a triangle on top, and you're gonna shade all the way through the triangle on bottom. What is their combined area gonna be? Because the triangle top and bottom are what? They're the same size, they're gonna cancel each other out. So for this last one, it would be. Okay? All right. You have a big chunk of time to work on your homework because it's a little bit long, but you can't do all of it today. I'll tell you where to stop. Y'all want some the ratchet paper? Daniel, do you want scratch paper? Yeah.
Regular things. Veracino got it. Chillax, bro.
Yes.
Saying that word, chillax.
Okay. Seems such a loss now. Go on paper. Paper? Do you need paper? That's what you need? Rebecca, what about you, little silly girl? Give me the homework with geometric integrals.
No, I mean, what's the email?
It doesn't matter.
We're splitting that.
Dog, we need the paper? I want a little water. Brighten you up a little bit.